Thank you so much for the introduction. This is my first Koli Calling, and so I feel really privileged to be here as your keynote speaker. So there are many kinds of keynotes that people can give. Some keynotes present research, some are retrospectives that reflect on a career. Some keynotes are outsider keynotes that bring ideas from other communities. I'm not going to do any of those types of keynotes. In fact, this is not really a scientific talk, but a political talk about science. I want to talk about which research questions we choose to answer and how those research questions apply to the world. So this is going to intentionally be a provocative talk. I want to spur debate, and I want us to continue that debate throughout the rest of the conference. So before I provoke, I'd like to celebrate a bit. The computing education research community is just an awesome community. I've participated in many fields of computer science, including human-computer interaction, software engineering, and programming languages. And computing education is by far my favorite community. One reason for this is that we have collective missions. So let's talk about some of these missions. From about 1970 until today, we've had this massive collective mission of how to teach programming effectively, equitably, and at scale to post-secondary students. We haven't quite figured out how to do this well, but we definitely have better answers than we did 50 years ago. And I believe that even though we can't really know, that this is having a great impact on the quality of the programmers that we graduate, for example. But we've also started some other recent collective missions too, maybe around 2000 until today. One of them is, how can we equitably and effectively teach computer science to every child in primary and secondary education, not just post-secondary education? Another one is, how can we ensure that everyone feels welcome in computing, not just white and Asian boys and men? These are really challenging problems. They're problems we've really only just started on, but we've already made a lot of progress and impact in various settings from these. Of course, these are more than just pedagogical questions. They are questions that directly tackle the racism, sexism, and ableism in computing culture. And as computing continues to eat the world, these problems of representation are far more important than ever. So I'm committed to working on these problems for the foreseeable future, as well as the problems of programming pedagogy. And by no means are we done with these missions, but I do believe that there are bigger problems that deserve our scarce attention as researchers. I want to spend the rest of this talk trying to convince you that some of our attention, maybe even most of our attention, should go to these bigger problems. So here are some of the problems that are on my mind. Maybe they're on yours too. First, automation amplified by computing may be causing global economic disruption. We might not even see this coming, but this may be happening and is already happening in some obvious ways. For example, this is a photograph of a modern car assembly plant. It used to have thousands of highly paid mechanics, and now it's a smaller team of lower paid maintainers and much more skilled and trained people who are writing the programs that control those robots. I'm afraid that automation like this without retraining will cause massive economic disruption, and that we're really not prepared as a society for what to do about this. Even if jobs come, they may come slowly and they may require way more advanced skills than ever before, and this transition is going to be chaotic, destabilizing, and possibly deadly to some. So here's a second problem. Climate change is causing mass migration, natural disasters, and political upheaval. This is a picture of the 2019 Chennai water crisis in India, caused partly by more unpredictable rains, but also partly by poor water management, which is really emerging from a lack of data and data tracking about water. The world is doing very little to prevent harms like these around global warming and climate change, and we're really not prepared for the kinds of chaos that this is going to bring. Third, disinformation is amplifying these trends, destabilizing democracies. Every single day in the news, we see a news story about how somebody is using and abusing social media in order to change the way that the world thinks about what's a fact and what's not. This is a photograph from some of the protests in Hong Kong, where government officials have used social media to spread disinformation about where protests are being organized, for example. Our democratic institutions are under attack, and the weapons are social media. If we don't find ways to prevent software from amplifying misinformation, trust is going to erode, and our democracies might collapse. Finally, one of the other bigger problems that's very close to home for me is the consequences of these problems are falling upon our most marginalized people. This is a photograph of a tent city in Seattle where the homeless population has risen rapidly with the growth of Microsoft, Amazon, Google, Facebook, and Apple, and their satellite offices in Seattle. And some of these companies, most notably Amazon, have spent millions of dollars in just local city council elections fighting against taxes that offset the harms of rapidly increasing costs of living that are caused by how much these companies are paying their software engineers. So solving all of these problems by creating more engineers is really only going to create more problems like these unless we think about new structures and new ways to think about how to grow around automation. So what do these have to do with computing? Well, I want you to think for a moment about the links between what we research, what we teach, and these four problems. What is our role in causing these problems? What is our role in solving them as researchers? I would argue that our role as computer scientists and as computing education researchers is actually pretty central. And I think the way into that argument is really to talk about values. Values in computer science have really amplified all of these problems. Computer science, for example, values efficiency over humanity. We treat it as if automation is always a good thing, but it's not. As computer scientists, we value convenience over sustainability, as if computing resources are always free, even though they're not. Computer science values neutrality over truth, as if a bit has no meaning, and as software doesn't have an opinion. But software does have opinions. We put those opinions into them. We embed them with values. And finally, computer science values competition over equity, as if society is a pure meritocracy, even though it's not. These may not be the values of the people in this audience, but they are certainly the values I was taught as a computer science student. And I would argue that they are the values of the broader academic computer science community. They're the values that we use to determine who to invite to learn with us. And they're the values that we teach, sometimes implicitly and sometimes explicitly in all of the classes that we teach. However, because we are the ones that teach these values, we're also positioned to change what we teach and change the values of computer science. We can prepare the students to be more mindful about the limits of computing. We can teach students to be more responsible in which jobs they choose and which products they create. We can ensure students are literate about the data and its potential for harm and how software amplifies that harm. And we can show students that diversity in human experience has to be designed for intentionally. It doesn't come for free. And if we teach these things, our students will change. And if our students change, then the software industry changes. And if the software industry changes, the world changes, because really the world is undergirded by software infrastructure. So here's my concrete proposal that I want to walk through in the rest of this talk. I argue that our most urgent global problems demand that we integrate 4 big ideas into computer science curricula that are currently not there in primary, secondary, or post-secondary computer science. The limits of computing, social responsibility, data literacy, and designing for diversity. These are areas of knowledge that are largely missing from all of our different levels of CS education. They're largely missing from our learning standards and curricular guidelines, and they're largely missing from our research as computing education researchers. So for the rest of this talk, I'm going to talk about these 4 topics around these issues, and then give a call to action about what we might do to try to address some of them. I'm going to try to convince you that all of these are key and identify the role of research in shaping how we teach these. So I'll begin with the limits of computing. I think we all can agree that computing is powerful. It powers our planet, literally. You know, it's increasingly powering our commerce and our social lives and social media. But there are a lot of people, including computer scientists, that believe that the power of computing always makes things better. Technology trade shows like CES paint a picture of the world in which software and gadgets make our lives increasingly and incrementally better. Of course, the reality is that sometimes computing makes our lives worse. So let's talk about a few examples of this. In the United States, some judges are automating sentencing because they believe that machine learning can't be wrong. Somewhere, a software company in the world decided that it would be a good idea to take these sentencing judgments that have currently been reserved for judges and automate predictions of the likelihood that somebody would recommit a crime. Rather than leaving this to the judgment of judges, the software used prior crime data to predict future crime behavior and did this partly based on racial categories. And so Black defendants were being sentenced not because they as individuals were likely to recommit a crime, but because Black people in general were more likely to recommit crimes. And this is not something that should be left to statistics and algorithms. The software designers who chose to do this did so because they trusted algorithms to be right, and they conveyed that trust to judges. So we failed here to educate the designers, developers, and judges about these potential harms. Here's another example. Faith in technology to solve any problem is often used as a justification for inaction on climate change policy. This is a picture of the 2015 Paris Climate Agreement, which set global carbon reduction standards. But if you read each country's plan, you'll find that they're far less dependent on policy change than they are on the faith that advances in technology and automation will save us. This faith in the power of technology is really preventing the exploration of more impactful policy changes. Here's a third example. Belief in algorithms being neutral has concentrated power in Facebook, Apple, Amazon, Netflix, and Google. This is a picture of Mark Zuckerberg at the US Congress in 2018 testifying about disinformation and censorship. In it, he expressed the belief that Facebook is neutral, that it's a neutral party that supports all speech. He expressed faith that automation could even scale the prevention of disinformation without censorship. And the reality, of course, is that Facebook is not neutral at all. It actually employs thousands of people to manually apply its censorship guidelines every day, and those censorship guidelines are not democratically shaped, but they're determined by a team of private Facebook employees instead. And so the public lost this control because it trusted algorithms to be neutral, and now it's in a process of trying to regain some of that control in small ways. And finally, one last example. Developers are spending their time making apps to solve homelessness rather than actually addressing housing costs, which cause homelessness. This is the landing page of a mobile app in Los Angeles, California, called Lease Up. Of course, nothing about this app actually solves homelessness. The critical feature behind this app is the organization behind the app, called PATH, which is a state-funded nonprofit that matches homeless families with landlords. What makes PATH work? Well, it's actually a $25 million budget line in the California state budget that supports PATH to actually do this matching process. That's the service, and those are the resources that actually make this work. And solutions like this misattribute their impact to software, when in fact the impact is due to policy and money. And so when you think about these four examples, I think it really points out that everybody in the world needs to know that software is often wrong. It's garbage in, garbage out. That software isn't neutral. It expresses the values that are encoded by its makers. That software isn't free. People have to make it. Energy has to power it. And that software can't solve every problem. No software is ever going to solve poverty. That is going to be an issue of money, commerce, democracy, and beyond. Now, if everyone knew these limits, we might have a different future. Judges and driverless car users might have less faith in algorithms to make autonomous decisions, and this might prevent death or lifelong imprisonment. The public might be more skeptical that technology alone will save us from climate change and instead promote policy change. Consumers might be more mindful about the price that they and others are paying for a free internet, catalyzing regulation, just as has happened in the European Union with the GDPR. And developers might spend less time making unhelpful apps and more time advocating for meaningful social change if they didn't believe that apps could solve everything. Now, you might think that teaching people to code is enough to teach them the limits of computing. But I would argue that teaching everyone to code only strengthens belief in the power of computing. When people learn to program, they come to believe that programming is powerful, that programmers are powerful wizards who can do anything. They learn nothing about what programming can't do. They only learn that smart people can make computers do anything. So I would argue that to teach the limits of computing, we actually have to answer some really big open research questions. How do we teach the limits of computing in a way that transfers to everyday life? How do we integrate these ideas into all primary, secondary, and post-secondary education, both in CS classes and in non-CS classes? And how do we prepare teachers at all levels to teach these limits of computing in transferable ways? So we need to teach everybody both the power and the limits of computing. I think a second and equally important idea is that of social responsibility. This is the general idea that every person in the world who has responsibilities that go beyond their self-interest. For example, this is a photograph that shows US citizens taking a day off from work to vote in the United States. This is an example of a responsibility that we have not just to ourselves, but to everybody in the nation. So when we teach computer science, we mostly ignore social responsibility as a dimension of what skills somebody has to be able to enact as a computer scientist. Here's an example. Most CS education is agnostic to what students choose to make. We focus on programming, and we focus on whatever students' interests happen to be, whether that's games or apps or getting a job or making lots of money. None of those things are inherently bad, but it's that we don't talk about any of the other things that should shape students' decisions about what they choose to do with their time and their skills. And of course, what students choose to make actually matters. Here's a picture of an adolescent who chose to investigate the effects of climate change in their project. She could have made a cool robot instead, right? And those are two really different actions around developing her skills. Which one would have had more impact on preventing the worst effects of climate change? Here's another example. When students become professional developers, what ethical stance against automation should they fight for? This is an excerpt of a letter from a coalition of Google employees advocating for the cancellation of Google's Dragonfly project, a censored search engine for China. 626 Google engineers signed it, making a strong statement that they did not believe that this was the right thing to build. So why did Google engineers feel empowered to make this stand? And more importantly, why did the other 15,000 Google engineers not sign it? Was this purely a political stance, or was this their fear of actually expressing their opinion in the context of their engineering work? Here's another example. Should students' first jobs be e-commerce at Amazon or sustainable energy? Here's a Stanford computer science job fair, for example. Why is this fair full of Google, Amazon, Facebook, Apple, Microsoft, and finance and media companies? Where are the green energy startups? Where's the anti-poverty advocacy groups? Where are the government organizations, all of whom are desperately in need of great software engineers to make their missions work as well? And finally, should our graduates innovate in social media or in sustainable business models for ethical journalism? This is a map of counties in the United States with no local newspapers because they've gone out of business due to social media. They've really gone out of business because social media is free and has consumed everyone's attention. So why do our students go to Twitter, Snap, WeChat, TikTok instead of saving journalism? Well, why do students ignore these problems? Partly it's because wealthy companies are better at recruiting. We do little to show them the alternatives in higher education. Students want to work on new technology, but we rarely talk about applications outside of consumer technology from the ones that they're familiar with in marketplaces. And a lot of students value wealth and status, but we rarely attempt to change their values by talking about the other kinds of things that matter in life. And so what should we teach? I would argue that every developer needs to know a few basic things. The problems they choose to work on will shape the world, and so those choices they make are important. Where they choose to work, the organizations they select, will determine the problems that they work on. And if they don't like the problems that businesses are working on, they can create their own businesses that work on different problems. They should feel empowered to do that. And to make these choices, we need to help them develop their values and their ethics, as well as their entrepreneurial skills, to give them agency to actually see the world that they want to see, rather than feeling beholden to the companies that exist currently today. So if our students had different values and made these different choices, we might have products and services that augment human ability rather than trying to replace it. We might have more products and services that address climate change. We might have a more robust free press and therefore a more stable democracy. And we might have more effective public and private services for people with the greatest needs in society, rather than just services that serve really the elite. Now let's come back to the same question. Does programming teach these values? I would argue no. Educating great programmers will not teach social responsibility. I believe that when people learn to program, they come to believe that programming is about puzzle solving and not social change. And that developers' responsibilities they view as really purely technical and not social in nature. Developers learn nothing about the role that they play in shaping our products, our services, our governments, and our communities. But they should know about those things. So for our students to be socially responsible, we have to teach them to be socially responsible. So how do we do this? Well, these again are some big open research questions. How do we convince students that they are responsible for their technical and career choices? How do we prepare students to make socially responsible career decisions across their lifespan? And how do we empower students to start socially responsible software companies through entrepreneurship? There's almost no research on any of these questions in the context of computer science, and there's very little teaching happening on these topics with a few exceptions. So everyone should know the limits of computing, and every developer should embrace social responsibility. This third area of knowledge I'd like to argue for is data literacy. And when I talk about data literacy, I really do mean boring things like this entity relationship diagram for this e-commerce data schema that details orders and items and customers and products and other metadata. And it's because in these boring things are actually really pernicious, challenging problems. So to try to reveal these, sometimes when I'll teach about data to students, I'll start off with pictures like this. Here's Google on the left, and here's Google on the right without content. This provokes a lot of important questions. What is more important about Google? Is it the algorithms that index and retrieve content from the web? Or is it the content on the web itself? All of that data that's sitting around waiting to be harvested, indexed, and used. And this provokes other questions. Where does all of that content come from? What makes that content useful? Google's value really is created by other people writing content, not so much by Google itself. And computer science really does ignore mostly the power of data and content. When people think of Facebook, they think of its apps, they think of all of the algorithms, they think of the underlying internet infrastructure that makes it work. They often don't think about the content that billions of people are giving Facebook for free every day that make Facebook valuable. And when people think about machine learning, they think of machine learning algorithms, not the data required to power those algorithms, and what it takes to produce that data, to maintain that data, and to repair that data over time. Of course, data is central to computing, and it's often the source of the harms caused by computing, which makes it a very central topic that students need to know about. So let's talk about some examples. Take facial recognition, for example, which often use data sets that have really severe race and gender biases, but that law enforcement uses anyway, at least in the United States. This is a picture from a Microsoft research study showing that facial recognition algorithms consistently underperform for darker-skinned women. Everyone needs to understand that machine learning is garbage in and garbage out. If your inputs are bad, biased, or unethical, your outputs will be bad, biased, and unethical. But oftentimes students don't recognize this. They just see deep learning and think that it's magic. Here's another example. Humanity's hunger for data, not algorithms, is what's driving the massive power consumption in data centers, which are a massive source of carbon output in our modern world. But people are often focused on light bulbs instead, and cars. Everyone needs to understand that the internet is not itself a sustainable thing. The web is not free, and loading a website actually puts carbon into the atmosphere. It's our desire for information that's driving these behaviors, not our desire for algorithms. Here's a third example. Social media companies have quickly learned that disinformation, right, data and content that is intended to spread misinformation, can kill, bully, violate, and destabilize in all kinds of ways. Examples of this are the Russian government targeting the 2016 US presidential election, which reached millions of American voters with phony posts and ads that sought to exploit division on hot button issues. The Russian government also ran a sophisticated social media campaign that included fake news, Twitter bots, unattributed comments on web pages. Clearly, all of this damage is done by the content and not by the algorithms themselves. Algorithms are simply amplifying all of that harm, and yet students don't understand this. So here's one last example, this one more personal. Metadata used in machine learned models reinforce invalid models of gender, which just leads to harassment. So this is a picture from an airport security body scanner, the kind that you probably all walk through to get here. Every time I go through an airport, an agent looks at me and labels me as either male or female. And then a machine learned classifier, which was trained on those two different binary genders, on a normal set of male and female bodies, tries to identify anomalies on my body. Anomalies like a gun, for example. Of course, as a transgender person, my body is anomalous. And so nearly every time I go to the airport, an agent has to inspect my anomalies on my body for weapons. It's a horrifying, humiliating, and unnecessary search caused by really a normative set of data and features and then amplified by an algorithm. This is harm that data does that clearly the designers of this body scanner did not think about. And so everybody in the world, not just developers, needs to understand that data is an imperfect record and can often be entirely wrong. For example, my car title still says Andrew. Do I still own my car? Data is always about the past, which is not always an indicator of the present or the future that we want. For example, computer science is predominantly male. There's some data. Does that mean it always will be? And finally, data is always biased, encoding the values of the people who captured it. My medical record says, for example, that I'm female. Am I? And what does that have to do with my healthcare? So if our students had this data literacy, we might stop developers from using unbiased, incorrect, and unrepresentative data to automate the world. We might reduce people's faith in machine learning to solve every single problem and nudge them a little bit more towards policy solutions, or at least improvements to data. We might grow demand for better data privacy rights, like the GDPR and whatever comes after it. And we might prevent computing from amplifying bias in the world because of the recognition that that's the role that computing is really playing in the world. Now, you probably know at this point what question is coming. Does programming teach this data literacy? Again, I would argue that it does not. When people learn to program, they come to believe that data is abstract, that it's free of values, that it's free of meaning and free in general. These ideas about data come originally from things like Shannon's information theory, which really talk about data as sort of value and meaning free. But second, students also learn that algorithms are the primary lever of computation and not data. Not only is this not true anymore with machine learning, but it never really has been true. Instead, they learn nothing about what data is, how it's limited, and how algorithms can amplify the harm of data. And so for our students to be data literate, we have to teach them data literacy. And that means answering, again, some big open questions, such as how do we teach the limits of data in a way that transfers to decisions in everyday life, and also in software engineering? And how do we integrate ideas about data into all of primary, secondary, and post-secondary education, both in computer science classes and non-computer science classes? And how do we prepare teachers at all levels to teach the limits of data in these transferable ways? So I've discussed three major ideas about computing that I think are missing from our conversations with students. Now I want to turn to an idea that underlies all three of those ideas, and that is diversity. Let's just talk briefly about what diversity is, just so that we're all on the same page. Diversity is just a fact of nature and society. People are different. That's really all that word means. But it's a fact that's often ignored in the design of software. And it's also a fact that's at the foundation of those three areas of knowledge that I've proposed. So let's discuss each of them and how they're related to diversity. First, diversity limits the power of computing. It is diversity itself that causes this limit. Automation often can work great for really normal or average cases, but the fact of diversity guarantees that many cases will not be normal. Whether it's deterministic algorithms or data-driven probabilistic reasoning, software struggles with diversity, and students often don't know this. So whether it's economic change or climate change or political change, abnormal really is the new normal, and our software isn't designed for this. And our students aren't ready to design software for it. Now let's turn to social responsibility. Diversity increases social responsibility. And it begs this question, what exactly are CS students responsible for? Responsibility is about duties to others, especially when you're in a position of power. And so I would argue that in disrupting every facet of society, computer science has become responsible for everything and everyone that software touches. Programmers build our healthcare systems, our transportation systems, our financial systems, our educational systems, our social lives, and our entertainment. That means that our students don't even recognize the power that they have, and we don't really educate them to use it responsibly. And lastly, diversity and data literacy. I want to equate these two in a way. Data literacy is really about understanding diversity. Data can do harm, for example, precisely because of diversity. Data bias, disinformation, data privacy, these are all fundamentally about who's represented by data and how they're represented by data, and whether those decisions that are made with data are reflective of that diversity. Our students just don't comprehend the true meaning of a bit and its ability to entrench power, to warp society, and to destroy lives. So if we take these three arguments together and we return to my home of Seattle and we really think about homelessness, for example, all of the decisions that software developers make are really sort of ignorant of that diversity. And that's what often leads to some of those problems. So every developer needs to know that it's because of diversity that computing is limited. It's because of diversity that they're responsible. And it's because of diversity that data does harm. And so if a developer ignores diversity, they're ignoring a central property of software as a medium and a tool for change in the world. Now, if every developer knew these things, developers might seriously consider not creating something because of the harm that it might do. Developers might choose projects that help everyone rather than people just like them. Developers might acknowledge the power that they have to make or break democracy. And developers might recognize that the world is far more complicated than they think, and that might humble them a little bit. And so we'll return to this question for the last time. Does teaching programming teach diversity? I think the answer is pretty obvious in this case. Teaching everyone to code will not teach how to design for diversity. When people learn to program, we teach them things like the simple average cases for highly abstracted problems that are divorced from society. And we teach them that good design is a computational matter, not a social one. They really learn nothing about the diversity of humanity or society or how software design choices interact with this diversity. Today, most of academic CS doesn't view these as part of computer science, even though they should be. And so for students to be diversity literate, we have to teach them about diversity. And again, to do this, we have some big questions to answer. How do we teach diversity in the context of computing in a way that transfers into those software design contexts where people are making choices about how to represent these? How do we prepare developers to design for outliers instead of averages? That's a completely different kind of design process and something that we don't really have good answers to in the software engineering world. And how do we prepare teachers to teach these ideas? They're often getting training about diversity, but not thinking about how to teach computer science in that way. And it's our job as computing education researchers to answer these questions and then teach those answers to everybody across the planet. So I presented 4 things that I think are missing from CS education: limits of computing, social responsibility, data literacy, and diversity literacy. And I've argued that teaching them could reduce harm, it could save our democracy, and maybe even save our planet. Now I want to convince you that it's our responsibility, mine and yours, to catalyze this work. And first, remember that our community is awesome. We know how to tackle big problems. We know how to work together. We know how to work on problems that matter to computer science. I would argue that the only thing we don't do is work on problems that matter to the world. And so to prove it, here's some data about what we've been talking about at this conference in past years. Here's what we talked about at Koli in 2018, better ways of teaching programming, understanding student misconceptions, describing and critiquing curricula, and assessing programming knowledge. And we're pretty much talking about the exact same thing at Koli 2019. Answering these questions will not prevent economic collapse. It will not prevent climate change. It will not prevent the spread of disinformation, and it will not prevent marginalization. In fact, progress on these problems might only reinforce some of these issues. So here's what I'd love for us to be talking about at Koli 2020 next year: effective ways of teaching the limits of computing, effective ways of teaching social responsibility, effective ways of teaching data literacy. How do we integrate these topics into curricula? How do we assess this knowledge? And how do we teach programming in a way that doesn't break all of these understandings? These are our computing education grand challenges for the 21st century. Let's start the work right here, right now, because we are the only community positioned to actually answer these questions and change computer science education. It's our responsibility. Thank you.